Hey everyone, today we're gonna learn about Revit API basics in depth and everything that revolves around Revit API. So let's go over some topics that we're gonna cover. So the first topic that we're gonna go over with is Revit API itself, right? So just basics of this. And that is going to be in-depth tutorial, right? I think you'll probably get this by the duration of this video, right? But my main goal here is that this video will serve you as some sort of preparation for Revit APIs, a prior step that you need to make before getting into Revit APIs. So you remove this magic layer. So for me, what is important to me, what is important here is that you're not just jumping straight into coding, but you actually remove the magic layer. So by magic layer, I mean that you are as the user and here that magic API that you're using, and you have no idea how is that even possible that you use it and all these things, right? And between this, you have this magic, right? My main goal is that we remove this magic layer so you actually understand what you're doing and why that happens the way it is. Also, topics that we're gonna cover is that why Revit? I'm gonna write this in the tree-like hierarchy. Why Revit was even developed. So this is the next topic that we're gonna discover, and all of them are very important to just understand the idea of what an API is, why it looks the way it looks, and just a better feel of why it was developed this way and whether it's good or not, but I'm not the one to judge. Also, you're going to cover topics like what is the difference between user interface, right, which is the topic that you're probably familiar with, and actually API. And also, what is my one of the approaches that I'll be using is that we're going to make tons of analogies with topics you're probably familiar with. So that's the learning approach I usually take um, to grasping and comprehending new information, to actually stack new stuff that I learn on top of what I already know, and I draw a lot of analogies with it, make a lot of comparisons, so I kind of understand it better and solidify everything that I learn. Also, we're going to go through stages of Revit development, which can be quite important to understand how Revit was developed, what process it went through to get where it is. So, stages of Revit, Revit development. So this is another topic that we're going to cover. Also, you're gonna learn like inside these topics about things like not OP but domain, like terms like domain, probably that not a lot of people in Revit API talk about, especially when you watch some tutorials. But I really want you to be confident before getting started with Revit API and to just get the idea of these terms that are vitally important for development. Also, you'll understand basic object-oriented programming skills. Uh, Therefore, you'll be able to read Revit API docs, how to navigate through Revit API docs, how to read its information, how to read information from Revit elements, right? Not via code, but just by using some tools that allow you to just investigate and explore what it contains behind the scenes. Also, you'll learn about what is a plugin, right? All these terms like plugin, Addons, right? And all these topics are going to be covered pretty much in depth. So plugin, Addons, and the main question is how Revit even allows us to add new functionality, right, to an existing app. And you'll understand the whole idea that whatever we do, right, whatever commands, whatever functionality we write, We're just giving this to a different kind of application. It's not our application. It's like we're passing files to this application and it consumes it, and it's the responsibility of that app to perform things with this with the files that we pass to it. Also, here we'll understand what types of add-ins we have, and just anatomy of this. So anatomy of this. So just an idea of what it consists of. So this is regarding topics like um, what we're going to cover. The next thing, prior to getting started with all these concepts and ideas and information, I would like to I would like to share with you what content can you expect from me in the future. So the first one, more YouTube stuff. So a lot of YouTube videos are on the way, including the creation of plugins and topics related to programming. So there will be tons of content about development, about plugins, about different reflections that I made based on plugins creation, what I think about this, and using different paradigms to develop plugins and so on and so forth. There will be a lot of interesting content on the way. The second thing, um, I'm about to finish my website. My new website will be finished within 2 to 3 weeks, right? And it will contain articles. That's the first thing that it will contain. So y articles that are complementing the videos I create. So for each video, you'll get an article, and probably that article will contain additional exercises and just more in-depth data. So you can go there, solidify everything that you've learned, easily repeat this, and get just some insights the way I consume and grasp information. Because in addition to programming, I also want to cover topics like what are the best ways to learn information? What are the best way to just understand how to problem solve? So there will be a lot of content out there as well. Another thing that will be on my website, but it already exists, meaning the course, the paid course about Revit API that I have. This is for people who are prefer learning in a video format. So you get videos, you're added to the chat where we have more than 70 people already, and you can have a direct contact with me. You can ask any questions you want regarding the course, regarding topics in the course, or just about programming and whatever bothers you, in regards to programming probably. So it's basically video plus interaction, but it's not live, right? So you just watch videos on your own, you solve exercises. It contains a bunch of exercises, and you can easily communicate with me, ask some questions, and so on and so forth. This course is already available. You can hit me up by the email I'm gonna put in the description. So if you want, I will be happy to provide you with more information. The fourth thing is that if you prefer learning in a live format, so if you want to actually, let me type it this way, live format. If you want to learn this, if you want to have this interactive feel, when you go to a Zoom meeting and you like this lecture style things, when you're watching me explaining stuff, and you can ask questions on the way, and then you are given exercises and so on and so forth. If you prefer more of a live format, I've collaborated with Krishna and Sagar, uh, and they asked me to be their mentor, the mentor of the course. So I created the whole program and everything related to the course, meaning the content of this and the way I put it, that is on me. Therefore, if you like the way I explain things, if you like the way I kind of put things on YouTube and the flow I use, the way I speak. I don't know what criteria you may have If you just like the way I do this, you can also find the link to the Discord channel. And if you want, we'll be happy to have you on board and teach you a lot of great stuff in just in a different format, in a live format that that can be great for a lot of people as well. So this is what I'm up to. So that's it for this kind of part. And let's jump straight into learning Revit API and everything that revolves around it. Let's start with understanding Revit API. So Revit API. So we often hear about the Revit API as if it's some sort of like a magic pill, right? So it will be like some sort of magic pill that will help us solve all of our tedious tasks, right? So we have various tasks related to Revit, right? And basically by utilizing the API, we can get more creative, right? Because we'll spend less time on doing something repetitive, and something mundane, right? So we'll get more creative and our job will get more interesting, right? And to some extent, that can be true, right? If you're knowledgeable, right? If you know developing, if you know about development, if you know about BIM plus Revit, you can build good tools, right? You can build good tools because developing development is important to actually create softwares, BIM processes, and Revit. This is kind of the knowledge that is important for you to make useful tools, not just tools, but useful tools. So that's why it's important. But before even getting into all these topics, right? All these like before even getting into these terms and jargons like automation, Revit API and stuff, we gotta understand two main things that I think is vitally important for you to not only get an idea of API, but also for your future development. So the first part is why. So why Revit was even developed. So by answering this question, you will get an idea why the API looks the way it is. And maybe eventually you will get you will ask yourself more questions. I genuinely believe that that this kind of reflection, when you're asking yourself questions, when you're going through some stuff that you're working with, and you're trying to understand why that happens this way, that can help you a lot in understanding a lot of things, right? In basically removing the layer of magic. So why will eventually help us understand API better. And then we have, and let me kind of show here, this is that magic layer, right? So let me even draw this here. So if you are as the developer, right, you're using some tools like Revit API, it may use something else inside this, it doesn't that matter, but you're using any tool API. And usually between this, you have some magic layer, some magical layer that you don't worry about, right? You just do things the way it is, right? You don't go into you don't learn fundamentals to actually remove this. So my main goal is that by answering these questions, we will allow to remove this layer of magic and be able to understand things better and eventually solve problems in a more efficient way. So that is the first part that we will do. And the second one is understanding of the UI, something that you already know. This is the way I like to learn information. So we have something that we at least have an idea of, right? UI, probably all of us have a basic understanding of what is a user interface and what purpose does it serve, and we will map it to what is an API. So we'll try to understand. As you can see, eventually these tasks, right? These tasks will lead to understanding of API better, and we'll remove magic layer. So at the very beginning, they may seem like we're just spending time on useless things, but believe me, they will be quite useful for further understanding. So let's start with why. So why it was even developed? Like what causes apps to be even created, right? What prompted the creation of Revit? So it all starts with with a fundamental truth, right? So the first thing that everything starts with is that business, right? So business encounters challenges. It can be different sorts of challenges, right? But as one challenge, another challenge, and eventually all of them are time consuming, right? They're time consuming. They're hindering the productivity and efficiency. That's the main thing, and we lose money because of this. So if we look at our industry, right, in the industry that we're working with, which revolves around architecture, engineering, like, and all these things, design, modeling, if we think about this kind of specific area, right, that we're working with, so this area that where we are working with, again, design, modeling, and so on and so forth, if we're thinking about this, we can identify a couple of stages that we went through. The first stage was manual, right? So when we would draw things by hand. And it's pretty obvious, right, that we've got a lot of drawbacks with this approach. It was time consuming. We would perform tons of repetitive tasks. Also, it was pretty limited, right, in terms of even like precision, flexibility. So that had a lot of drawbacks. And at some point, business understood that we gotta do something about this to kind of remove this tedious task because uh, drawing simple like geometry like lines, right? Because your manual drawing would be just a container of different kind of geometry objects like arcs, NURBS, and so on and so forth. And that was repetitive, right? It didn't require a lot of creation when it's like the same, when you just repeat like drawing a bunch of the same lines. So, with all this digitalization and all that stuff, there was an app that was created that is called AutoCAD, right? And AutoCAD, it was quite a significant leap forward, right? It actually revolutionized the design process by digitizing it, meaning uh, you had this on the paper. Now you move this to the digital form, let me start, to the digital form, and that can be processed by a computer. So that's already some sort of some kind of automation. And that lead to like faster drawing, right? So faster drawing. We've got like the reusable components and other things. So we've got a lot of benefits for this. So we already kind of achieved quite some automation here. So we were doing things faster. We were working more with some intelligent components like blocks where we can put some logic, and the workflow was faster. And probably I'm not a very proficient user at AutoCAD. Right? I'm not a very proficient AutoCAD user. Uh, I just played around with this for a bit, but what I understood is that probably when you just get started with some software, you think that that is just perfect, right? That especially when believe that when people came from this manual to AutoCAD, I think that they just think that that is some sort of magic and that is amazing. But with time, right? Time passes and we understand what we spend a lot of time on, and that is not very productive, right? Things that can be made faster. So if we think about Revit, right? I'm not quite sure like all the great things that probably did to us. Because I'm not I wasn't an architect or software engineer for that long. But the main idea, right, that here now we have more intelligent components there. Now we're adding, like, in addition to just 3D modeling, right, with this kind of synchronization, when you change something on one view, changes on the other view, collaboration. Also, we have like rich objects here, like walls, floors. So now it's not just solid, it's not just line. So we've added, so it solves a different kind of problem, right, that AutoCAD solved. So the main idea here that I want to pinpoint in this question, why Revit was developed, is that all this kind of evolution from manual to AutoCAD to Revit, that is simply it just reflects the evolving needs of the business world. So everything starts from the business needs to do something, and eventually, like, in your own applications, right? When you develop your own apps, usually you listen to business and understand their needs, their problems, to actually build your application, which logic will revolve around these needs. So once we understood that everything starts from business, and whatever we do, any things that you as a programmer do, it basically the needs of business, right? So the next thing what I would like to discuss is that the creation stages of Revit, which I think would be quite interesting, and eventually we can kind of sum it up by understanding why it's important for API understanding. So let me go down there. So we understand that we got that everything begins with identifying business needs. So we identified business needs, right? They told us that we want to have this 3D modeling that would represent the real world, right? The real building, right? With a lot of useful information and so on and so forth. So we understood the challenges, but that usually these challenges came like from this business world. But now we gotta involve people who understand this area, right? So we have this subject area, which is also called a domain. But for the time being, let's think of this as just area where that basically it contains all that knowledge and all that useful information regarding the subject that we're working with. For example, in our case, that's 3D, that is like design, right? Because that is the primary tool for designing and designing actual buildings. So we gotta understand why the wall is created the way it's created, right? What is a wall, right? These questions are not answered by developers. These questions are answered by people who understand the subject area, the domain. They know how that should be done in the best way, right? They know what are the needs, and that can be architects, it can be structural engineer, so it can be there are a lot of people involved in there, right? Because it's quite a complicated thing. We have here the involvement of geometry domain, right? Where here we're mostly concerned with how that can be built geometrically. Uh, we worry about other domains like what would be a good way from doing it, from creating it from the logical perspective, right? Why wall is created the way it's created. That's probably the answer that is probably the question that is answered by I don't know by some architects or some engineers that know how how that what that should look like and how that should be created. So here we have this kind of huge subject area, right? We just call it a domain. We're going to get back to this term a bit later. But we also have, so we've got to have people who know a thing or two about this part, right? So, and also we've got people who are deve developers, right? Developers are tech savvy guys, tech savvy people who know how to actually create the program, right? And it's always about this communication. So people who understand the problem, people who know how that should be done, but they're not developers, they cannot create a program out of this, right? But they know how that should be solved in terms of what processes are involved, what are the best practices for doing things, and so on and so forth. And we have actual developers who can implement this. And to be honest, eventually, these developers should become these people who are really proficient at the subject area. To develop a software, you will need to dive into its domain. So I've mentioned a couple of times the word domain. And domain in software is basically a subject area, right? So we have subject area, and this subject area, it basically, as I mentioned here, it's 3D design, 3D design, it's BIM, so building information modeling. That's kind of like a subject area, construction and other things. So there's a lot of things in there. This thing is, it kind of is a representation of all the best practices for this, all the terms that are used here, and just everything that this area represents, right? It's basically like a description of this. And when and the people who know this are called domain experts, right? So domain experts communicate closely with developers, and eventually the program that we build, it revolves around this domain. So we have this area like BIM, 3D, and our program revolves around this. Meaning, if you look at API, for the time being, we're not quite sure what API is, but when you look at this, by understanding um, how that was built, you will simply ask yourself more questions. You'll do that self-reflection more. So uh, eventually, when you create a couple of plugins, right, I want you to stop and just ask yourself more questions and just reflect on what you've done. So how that can help us understanding these things, right? Now you are at least understand how products are built, right? So everything starts from business needs. We know this. It involves domain experts and developers. They communicate with each other, and eventually we've got program, right? So this is what we have. So that is that cycle. Eventually, that contains more cycles, but the main idea is like this. So now let's talk about the next topic, and then we'll kind of combine these two together and just understand what's the whole idea. So before getting to the next topic, let me ask you a simple question. What was the first thing you did when you decided to learn Revit or any other program, right? So what do you do when you want to learn a new program? What are your first steps? Okay, first of all, probably you look for some tutorials like docs, videos. It's all up to you the way all depends on the type of person you are, meaning whether you're like understand better and grasp information better by watching videos or just by reading. But also one of the first things that we do is that we get familiar with user interface. So UI, right? So this is what we get familiar with probably at the very beginning, right? Because that's kind of the thing that describes our application. And uh, we'll get to this interpretation later. But the main idea is that once we've went through this process, right, we already have a working program. And in this case, right, it's not it's basically in this case, it's a full program. But what I mean is that at some point when, let me draw that here. So when we got the core logic of our program, so we don't have any nice way. like any user interface, we just have core logic, right? We have built the core logic. Now we gotta make sure that it's user friendly, so anyone can go and work with this. Any like architect or software engineer, or not software engineer, structural engineer, or or engineers from other disciplines, they can use this software in a user friendly manner, right? Because we don't want them to know about these slow details. Because we have our core, right? So it's like the heart of the application. So that Revit, right? That's the core of the application. And we have users, just have you as for users, right? But we gotta have something in between that will allow them to use this software in a nice way. And that's where user interface comes into play. So user interface serves a purpose uh, of making the use of our application intuitive and easy, right? So our end users should go and simply utilize all the features that Revit has by having this nice UI that allows them to do things. And if we look at the Revit itself, right, that is actually a graphical user interface. It's not just UI, it's kind of like a subtype of it, which is graphical user interface, which basically buttons, different kinds of windows, and so on and so forth. So if you look at Revit, let me open any kind of project there. If you look at Revit, you have various tabs, you have various buttons. When you click on buttons, you may have some pop-up windows and so on and so forth. So this is a graphical user interface. So this is something that sits in between you and Revit. So if we look at the definition of the UI, it basically says that that is a point of human software interaction. So you have human, you have software like Revit, right? You have human, you have software, and we've got someone in between that, this point where we communicate. So that is that part that sits in between, some sort of intermediary like party that allows us for this communication, right? So that's what it's responsible for. And we have different types of these user interfaces. I'm not going to go too deep into this, but the main idea is that we have graphical user interfaces. So in Revit, you can click on buttons, you can see, check out some windows there. But also, if I go and I open you also have like command lines. So if I type CMD there, uh, that's a command line user interface. So by typing some commands like make directory, dir name, for example, you can actually interact with some other software that allows you to create directories. So that's the main idea, that we have various ways of communication with other programs, right? It can be via graphical user interface where you have nice buttons and other things. But also, what is important is that graphical user interface, and that any user interface, is a good description of what an application can do. So that is, let me, that is a good description. So UI equals to description of capabilities of what, let's, of what an app can do, right? An app can do of its capabilities, right? Of its capabilities. So it's like a description, because probably all features that we are including in our app should be accessed by UI, because what is the point of not having them there? What was the point of building them, right? So why is that important? How that can help us in understand the API? Because API, if you look at the API, API stands for Application Programming Interface. So Application Programming Interface. And now I want to compare the UI, because now it's something that we already know, right? I really like this comparison of what we already know to something new. And API. What is the main thing we understood from UI? is that we can have different types of UIs, like graphical user interface with buttons, windows. We can have command line. It doesn't that matter. The main idea is that we have two kind of users, right? Not two users, but two parties. User, right? You as the architect or other guy, or like people from other disciplines. And you have Revit, for example. Let's look at the example with Revit. You as the user and someone in between. So the main idea is that it's user, it's UI, graphical user interface. And the main idea is that we have user to software communication, right? That's kind of the main thing. So this graphical user interface allows us to do this. So Revit developers created it for you to communicate with this. But they also thought, you know what? We are doing this for regular users. But what if someone else wants to build their application on top of Revit? So they were like, okay, we have apps, so we built Revit. We've created graphical user interface to for users to communicate with our app. So users, graphical user interface, and okay, you got this idea, right? GUI and Revit. But they were like, let's do this for other applications. So some developers can create their own applications, right? Their programs, applications, and they want to communicate to Revit, right? We also gotta have something in between there, right? That is kind of obvious, right? That we gotta have something in between. For the users, they use just graphical user interface. But for programmers and their applications, they communicate via API. It's also an interface. And the main difference between them is who communicates with this application. So in UI, it's Revit with just a regular user. But in this case, it's application with Revit. So here we have app to app communication. So this is the only difference. So that's the main idea that you can grasp from this, that user interface and all graphical user interfaces that you see here, this interface is just a description of capabilities of Revit. But this is for you as regular user to work with this. So you can create wall, and if I go to 3D and I click on the wall, it kind of it's pretty user friendly in the sense that fills out a lot of data for me, a lot of default data. When I draw this wall on the level one, the line that I model is actually projected on it. So you cannot kind of specify here level one and draw a line and model this line on level two. So it kind of validates it. It makes it user friendly. So it's easier for you to use it. Uh, but the same goes for API. So if we go to API, here I have some like XYZ class, but we're gonna search for wall. So don't worry about classes and so on and so forth. The main idea that here, the same way we do this with Revit, which tells us click on the button, right? And then just fill out some data to create this wall. So we've got to draw a line, and that's it. That's pretty user friendly that's the only thing that we need to do. When it comes to API, it's not that simple, right? It involves more operations, and nobody protects you from making a mistake, right? To input some invalid data. This way, for example, here, Revit tells us that these things that can go wrong in the process of the wall creation. So that's not that user friendly in a sense that, you know what, here we protect you from making a mistake, but here you got to be careful with what you're passing there. But the main idea is that it's like a contract where we say, this is what you can pass, right? And eventually we tell you that we ensure you that we'll provide you with the wall. So this is the main concept of API. Its main idea is that we communicate with Revit. In our case, we communicate with Revit. It's just that they develop this for different users. So you can be as just an end user who uses Revit as an engineer, or you can be a programmer who builds their own applications, and these applications need to communicate, right, with other applications. If you look at some plugins, I don't know, maybe right inside, I just don't want to click on it, right? Or maybe Dynamo. Dynamo is a great example, actually. So if we understand how the dynamo kind of works in a sense, right? We're not going to go into deep, but how that works with the Revit API itself, because Dynamo allows you to communicate with Revit. So Dynamo has its own user interface. So the way you communicate with Dynamo, the way that communication goes, looks like this. You user you communicate with Dynamo via its graphical user interface, right? Because when you click on Dynamo, the UI appears, right? And you have nodes and stuff. That's the graphical user interface that is provided by Dynamo. And here, behind the scenes, we have Dynamo, which is the core logic for this, right? Here we have Dynamo, right? So again, we have someone in between that allows us to communicate with the core logic of Dynamo. But in turn, Dynamo communicates with Revit, right, with another application, and in turn, right, it communicates to this via API. So as you can see, when you will eventually your applications, your plugins for Revit will look something like that. Your applications that you build for Revit will have a similar kind of idea. So Uh, to sum it up, why that was important for understanding this user interfaces and why Revit was built, the main idea behind this is that now you understand, you get the idea that API is just a description of all functionalities that application provides. In our case, it's Revit. So if we look at this, we understand that we can create walls, we can flip walls, and do a lot of various operations on it. But by understanding why that was built and all this process from business needs, from domain experts and developer communication, you can understand why it's named this way. Why it's not named like why it doesn't have some other name, why it's named wall. Probably because that was the way business communicated with developers and they tried to made sure that their program looks like that domain, looks like that area that we're solving that problem for. So that is the whole idea. So these two topics are important for you to get to grasp the idea of why this named this way, why it looks the way it looks, right? And understanding of user interfaces, right? Something that you already know is important because you can draw a great comparison, a great analogy with this, right? The only thing that changes with API is who uses that app. In our case, that's developers. And the way we communicate with app, it's just via API, not via some graphical user interface. So this is the idea behind it. So now we know what Revit API is, but we still didn't know how to navigate through it. We didn't know how to understand, how to wrap our head around this whole like classes and everything that Revit API consists of. So we don't quite understand the anatomy of it. And before jumping straight into this, the main question is that why we even need it? Why? Why bother? Why we gotta know about Revit API? What kind of leverage, what kind of benefit does it give us? Because we learned that we can do pretty much all similar stuff via graphical user interface. When we have graphical user interface, Revit interaction, right? So let's go through a similar scenario. Let's say you're an architect and you need to place sections for room boundaries. So in Revit, you have a room, right? Let's suppose that it has these boundaries, right? And you want to create sections, right? So you want to have section for each boundary that looks like that. Okay, my drawing skills are not that good, but let's suppose it goes like that. So these are the boundaries. That's one view that looks there. Oh God, that is bad, but doesn't care. Let's suppose that here we create some sections. If we go to Revit, we can do this quickly, right? So here I've modeled like simple room, right? Just a room. And we would go and manually draw these sections, right? And we just do this for each of the boundary. And maybe based on some rules, you change the way it's built, right? So it can be a single section like this, or it may be like one here, one here, right, and one here. It all depends on your rules and how that works. Maybe if that is a rectangular shape like room, you can define some other rules for this and so on and so forth. So you can perform all this analysis by your own. So if probably it won't calculate that much of complex analysis on your own because you're like, okay, I can see that that is a rectangular room. You're not trying to prove to anyone that that is rectangular. You can see this. You don't need to write any formulas or other things. You just see this and say, okay, I just want to create it like I just want to create four sections for this, for example. Um, And so basically we can perform similar actions via API, right? Like section creation in our case, right? We can easily create sections via API, right? Via this app, via this app to app communication, or we can quite easily create them when we have user to app communication. And actually, if you do this for a single room and you just do this once, that's okay. We don't need any kind of way of doing this faster because that just happens only once. But that's probably the task, the kind of task that you do on a daily basis, something that is pretty repetitive. And each time you navigate to the room, because if you look at the workflow, what we navigate to the room, right? So we find the room in the model. Then we look at it and based on some analysis, based on requirements that we have, right, we draw sections. So we use section tool, we model elements, we model these sections, right? And then we navigate to the next one and again perform the same analysis and perform these repetitive tasks. So the main question is how we can leverage Revit API to help us with this. In the same way, you can look at Revit elements from its graphical user interface, like we have here, when you click on the wall and you see some common information of it, like what is that wall finish, what is this area, perimeter, and so on and so forth. The same way you can look at it from your program. So again, as we mentioned, we just have different kind of parties who communicate with it. In our case, that'll be our app. So the way element is represented can be differently, and that can be different, and that is different, right? When we've got the room, but it's called spatial element, but we're gonna focus on room. If we have room from user interface, it gets some info, right? It contains this area, right? Perimeter and other things. But if you go get room from API perspective, right? From the API, it contains more information on top of this. Because whatever you see on the UI, that's kind of gotten from there, right? That's just a representation of it. And it probably doesn't contain all info because you don't need that info as the end user. You don't need to know the info about the actual geometry that makes that room. So from the API, you can get like curves. You can get solid geometry of that room, right? For example, you can get some points out of this, all things that actually make it. And on top of geometry, you can also get some useful information about elements. Maybe you can perform analysis that are elements inside this and other things. The main idea is that it provides you simply with more info. And as you do manually, you can also perform just some analysis, right? So based on all your requirements, so you define requirements like when something happens, do this. And when something happens, do this, right? And a list of requirements, right? So here I have a bunch of requirements. And eventually, this analysis that you do manually, that takes a lot of time. And you can write this once in your program, and that it will be applied to each room that you want to create these sections for. So this is what is the power of this? That we can perform a single analysis, right? So we just create an analysis that does what we can do kind of manually, right? The same process, we'll look at some elements, right? We analyze it based on some computations, we get the result. But the main idea with this is that you're done this once and that's it. You have this functionality and now you can easily create this for different rooms. So you may have some functionality that simply accepts that room, right? And as the result, it provides you with like a bunch of sections that were generated, right? For example, list of sections that were generated for this room. So this is kind of the um, what functionality you could create. And that would be kind of your own API if you think about this. That's why I explain this, the whole concept of API, because that's something that you'll create on your own a lot of times, right? Eventually, you'll create your own API. So now you have a contract that says, give me the room, maybe some rules and other things, and I will make sure that I provide you with the list of sections that we generated for you. And here, between this, there is some magic happens, right? Something that is hidden from the user, right? Something that is hidden, because whoever will consume this, your own functionality, will don't know about the actual core logic, because that's logic that you will write, right? And then someone else would consume this. The same goes with Revit API. So to sum it up in this sense, the main idea why we use Revit API and why that can be powerful is that we can perform analysis similar that you perform just on your own, but instead of analyzing it each time for each room, we just do this once, right? We write the code that actually analyzes elements and provides us with meaningful outputs, and then we can reuse this multiple times, right? Now we no longer need to think about these things, about these analysis. So this is the main reason why we use it. That is the power why you should be motivated to learn about Revit API and what benefit it can give you. Now it's time for us to cover what do we need to know to actually understand Revit API docs, right? What topics do we need to cover to be able to navigate through its API, through the documentation of its API, and understand how we can use it. So prior to this, before this, I want to go through an analogy that will help us get more into this. So let's say we have a task. So we understood one simple thing, that we're all surrounded by problems. So in the world, we have a bunch of problems, right? And we gotta solve them some way. So let's suppose we have a problem. We want to create a door. So that will be a reusable component that we can place in our document, in our model, right? It doesn't matter what software you use, just an idea. So we have a task, right? This task um, this task started with the fact that we are sick and tired of creating the geometry from the scratch each time, right, to create a door. And we just want to create one reusable component and just place it multiple times. So let's generate, let's kind of have this test. So suppose we want to have a door which contains like panel, some handles, and so on and so forth. Doesn't that matter, right? The main idea is that it will contain of a bunch of geometry and that it will be reusable. So far, we haven't talked about what software do we use for this. So let's go through some of the main ones. So we have Revit, we have AutoCAD, we have ArchiCAD, right? ArchiCAD. I hope I spelled this right. The main idea is that the main question is that can we solve this problem in each of this software? And the answer is yes, right? Based like in each software, you can solve this problem. You can generate a reusable component a reusable door component that you can place in your model without repeating, like regenerating it, right? Without regenerating it. So we will remove this remodeling. But suppose we can solve it in each of them, but the main thing is what changes. If we compare each of the like each way of doing this in each of this software, what changes? There's only one thing changes actually here, and that is style, or let's say way. Style, way, pretty much the same, of solving it, right? Of solving it. So this is the only thing that changes. So we all get the same output, right? We have a door and it should be reusable. We have this door reusable, right? Reusable door. Let's make it nicer. It seems like I cannot. Yeah, let's make, we have this reusable door, and the only thing that changes is the style of doing this. And why it's the only thing that changes? Because each of this software comes with a set of principles, right? So if we go and say principles, principles, concepts, constraints, concepts, constraints, so it has its own business rules, let's put it this way. So when developers were communicating with these domain experts, each of them were communicating differently. Each of them communicated differently, right? And that influenced their decisions. But the main idea is that each of this software above, it just has its own rules, own constraints, own things, and that kind of puts us uh, in some style of solving it, right? So we achieve the same result. We've got the door, but we just use different styles, right? So here we have different styles of solving it. And this is what is called a paradigm. So in our case, that is called a paradigm. So we have the same thing in programming. In programming, we have a bunch of different paradigms that allow us to solve, that kind of dictate the style, dictate the way we go about solving the problem. Because each of them has its own principles, has its own concepts, and has its own constraints. So to understand Revit API, we gotta understand what paradigm did they use. We have a couple of paradigms like object-oriented programming, functional paradigm. We're not going to go over all of them because we're only interested in the one that Revit used. And Revit used object-oriented programming paradigm. So to actually understand this paradigm, you simply need to be aware of all of these constraints, concepts, and other things that dictate our style. Because if we go back here, oops, not something I wanted to, oops. If we go back here, we can see that we have different applications. They have different principles, concepts, and constraints, and they dictate the way we go about this. The reason why we can solve it in each problem because we're probably aware of all of these things, right? If you're a Revit user, you know how Revit is kind of is operating. Um, and for example, in Revit, we created using families. In AutoCAD, we use blocks. I don't know what we use in ArchiCAD, but probably that can be solved in there as well. But the way why you're able to solve this is because you're aware of this, of the way it operates. That's the reason why you gotta be aware of object-oriented programming paradigm. So we're not gonna go really in depth about this because that would take a lot of time there, right? But what we're going to understand is that its idea, this paradigm is centered around the concept of objects. So, and that is really why I think at the very beginning, right, when you're just getting started with programming, I really like that paradigm because that's the way we usually think about stuff in the real world. right? When you look at things, you think in terms of objects, right? Even right now, you're probably looking at a monitor, you have desk, you have chair, all of these things are objects, right? So they're objects with some data. So you can easily, that is so relatable, right? And because that's relatable, it's easy for you to grasp it at the very beginning. So if you think about your desk, right? If you think about your desk, that's an object, right? That has some information like what is that width? Let me, what is the width? What is the height? Right? And other things. It probably may have some behavior, right? So these are the data that it contains. So this is the data. So information. Also, it may contain some behavior. You know this. I don't know how do we call them, gosh, these desks that can go up and down. So you can work, you can sit or stand, it kind of influences the way you work. But the main idea, it may contain some behavior. For example, let's go with something silly like up, down, right? It can be like a TV also, right? When you have like a TV, and you may have some data about this, but you may also have behavior like turn off, turned on, and so on. So the main idea that that when we solve problems, so um when business identified problem, domain experts were communicating with developers. Developers choose this kind of paradigm to solve this problem. And this paradigm dictates given constraints. It has given rules that says we think in terms of objects. Okay, thank you. Uh, we think in terms of objects, right? So when we go about solving this, we're like, okay, business communicates about some walls, floors. So probably we gotta create them, right? We gotta have some objects that will be like wall, floor, right? And we don't care so far about the inner, the way it works behind the scenes, right? Just under the hood, because probably floor is just a bunch of geometry. Like in Rhino, we are working directly with geometry. In Revit, we just have another layer above that kind of makes this geometry more meaningful, right? It creates a rich objects that are more related to construction, to building information, right? BIM stuff. So this is why at the very beginning it's pretty easy to wrap your head around this because object-oriented programming is relatable to us. And if you think about something that you already know, something that you have worked with previously, you can find a lot of analogies for this. For example, let's get back still to this example with door, right? I just want to explain to you why it's easier to solve problems using object-oriented programming, especially when you're just getting started. Because if people say that functional is way much easier, but if you really deep dive into functional and its immutability and other stuff, and if you learn languages that really put a lot of constraints on you, you'll see that it's kind of not that easy to grasp at the very beginning. So let's have a task. Let's say we still want to create that door component, and let's say we work with Revit. Now we're not actually going outside of this software. We're focusing on Revit. And let's say you have a task to create a door family. So this is your task. Let's create a door family. So we gotta create door family. You can go about this using different approaches, right? The first approach may be, you know what, just open the door family file, which will be like a container of objects, and then you just put a bunch of geometry. So you model just geometry, like extrusion that represents panel, extrusion that represents handle, and different kind of sweeps, extrusions, whatever you want, right? I think if we do this, maybe do this pretty quickly. So here we have some default door family, right, that comes with Revit, right? We have just frame, panel, right? We don't have any handle there. But the main idea it's just a pure, so if you go there, you can see that's added extrusion. So that is simply just an extrusion. And that's okay for a simple family like this. But what if we have more things here, right? What if we want to like swap panels, swap frames, and do all other things? The main idea is that uh, if we solve problems in the paradigm similar to object-oriented, eventually that can be easier for us to understand how something works. For example, instead of creating each of this as just an extrusion, you can put this into a separate family and call this panel. This way, if we go back to our drawing board, now your family is not going to be just a bunch of geometry because this is just a bunch. I think I'm too zoomed, right? Let's go like this. Because now that's not going to be just a bunch of geometry, right? I'm not gonna spell it, right? A bunch of geometry, but now it's gonna be something different. Is that we're gonna have panel as the different component. Oh gosh, my drawing skill is really bad. So we're gonna have this panel that will live in a separate file in as a separate family. We will have handles that will live in the separate file. You can have frame that will, oh gosh, frame that leaves something somewhere separately. Again, I'm sorry for this kind of drawing. So frame, handle, and so on and so forth. And eventually you have this single door family that is composed out of these objects called panel, handle, frame, right? Frame, right? Eventually, that is easier for you to understand this, right? Think about this. When you open a family and it's just a bunch of geometry there, just a bunch of geometry, there are a lot of problems with this. First of all, if something breaks, you need to analyze everything. There are a lot of information for you to consume to to solve the problem, right? Because it's just a bunch of geometry. If you go with this example, you just have a bunch of geometry, and if something breaks, you got to analyze a bunch of geometry. But in this case, you're like, okay, there's something wrong with my panel. You don't touch this door family. You just go to the panel and work in isolation. So in this way, it's easier for problem solving and for understanding the concept, right? So it's easier for you to open a family, understand what it consists of because it's named meaningfully. It has door, frame, handles, and if something goes wrong, you know exactly where to go. So to sum it up, this concept, and we're gonna go after this, we're gonna jump to Revit and kind of explore this on its objects and compare it with Revit API. But to sum it up, we identified what paradigm was used to solve problems that Revit solves, right? To solve all the tasks that Revit is meant to solve, right? And that is that paradigm called object-oriented programming paradigm. It revolves, its logic, its this paradigm is centered around objects, right? So this is the actual things. So it's like a desk that contains the actual width. So width like 100, height is like it doesn't matter, right? Just the idea, right? Just the idea that it actual things. It also contains classes that we're not gonna go into this, right? We're not gonna explore this more. If to put it simply, classes, you can think of classes as just templates, right? As just templates. And objects, right? And objects are actual things, are the creation of these templates, right? The creation, the actual instances, creation of these templates, right? Of these templates. Because if you think about a wall, right? If you think about this, wall, uh, if we think about its template, we say, wall contains, so we have wall contains height, it contains width, probably, right? It may contain base level, but so far we don't have this information. It's just a template that says the template answers a single question. What does an element should look like, right? We don't have the actual value. We don't know that what is the height of this wall. We just say that this is what the wall looks like. So in Revit, if I go back to 3D, and I draw a wall, that's actually an object. That's an object because that's already an instance of this template, right? It says that unconnected height is 800. Like that is the length of this, that is the area of this, that is the volume of this. But class, in Revit, you're not working with classes, right? That much. But the main idea is that the class is just like a description of this. It's like ha having just this left side part, right? Without the actual data. It just tells you that, we should have a location line, we should have a base constraint, but it just describes what your element should look like. And when you create an object out of this, right, you just put the required data. So when you even create wall, you can see that here you're prompted with data that you need to pass. So this is based on this class because the class dictates what it looks like. And once you've specified all values and created an actual object, this already a real world component that contains information. Now we gotta understand documentation more in depth, right? We gotta delve into this and basically grasp the whole idea of it. So when you open documentation, that's like revitapidocs.com, that's where you can find this. So here I've selected, you can select any kind of version, like 2023, but even if you kind of remove this space, right, you have Revit API docs, you can search for something, or you can choose the version, let's suppose 2023. So the first thing that you notice is namespaces. So we already got familiar with two concepts, classes, which are templates, and objects, which are actual instances, right? It's like the real wall. It's not just the description of the wall, it's the actual instance of the wall. Namespaces are containers for these classes, for the classes. So it's just like more organizing stuff, right? Because usually, even when you work with BIM and with families, you try to put families into meaningful folders. So, it's not all over the place and it's easier for you to find them in the meaningful place. The same goes here. So if we try to, like, I don't know, that is required there. So if we go down there, you don't want to have all these things like all over the place, right? So you create some meaningful component, right? That it's like with family, right? So if you go door, probably that makes sense to contain here, like if you have like all handles, you can store them in folder whole, okay, called handles, right? And then you would have all handles. So that is equivalent to what we have with namespace, right? With namespace and namespace. Okay, I don't like the way I write namespace. So you can just have meaningful containers of different things. So the main one that we're going to be interested in is the Autodesk Revit DB, which stands for Autodesk Revit Database. We're going to go to the term database, but think of this for the time being as just a collection of elements that you have in your document. So everything that you have in your document in Revit, it's basically all these elements are just a collection of components, right? Everything that your document contains, it's the database. Database is just, think of this as just a bunch of items, right? So let's go to the example of the wall so we can understand this better. I'm gonna just type it so it's quicker to find. The first thing we see that basically Revit API consists of two things, namespaces, which are containers for classes, and classes themselves. So two things that you gotta understand at this kind of stage just to be able to navigate through documentation and understand this. Then you have wall class. At the very top, you see Autodesk Revit DB, which just tells you where it lives, in what container it lives, right? So it's like, going to your handle family and knowing the path to this folder, right? So it tells you where it lives. Also, it explains you some stuff, right? Represents a wall in Autodesk Revit. So you can read this description. You can see some examples in code using various syntaxes, some examples of it, and hierarchy. We're going to look at this a bit later. When we were talking with you about classes, if I go up a bit, we kind of said that we have a concept of classes and objects. And we said that classes are templates. They just describe the way your domain element, this element looks like, right? They just describe what wall looks like. They don't actually contain the actual value. They just describe the way it looks like. So if we look at the wall, oops, I should go to documentation. If we go to the wall, we have methods and properties. Properties are data that it contains. So here in our example that we drew, we had a desk which has width and height, but in this case, that's an instance. That's what we were looking at. Wall that contains height, width. So basically, by looking at its properties, you understand what data it contains. So if we were to create a human being, right, a human being, it would contain age, it would contain, I don't know, we can have height as well for the human being, right? Height, um, weight, and other sort of information. So basically, this is the data that you have, right? So basically, even if you think of you as a class, right? Uh, you are an instance of that class, right? Because you're already a human being, you have all this information. You have the age, you have age meaning you have the actual value for this. You know what is your age, you know what is your height. But you were composed out of this class human that contains age, height, right? That just data. You just contain data about yourself. But also, and if we look here, it says it can give us information about cross section of the wall, whether it was flipped or not, whether it's a stacked wall or not, its orientation, its parameter, its width. So by looking at this, we can get the idea of what wall looks like, right? Again, it's more of a template, it's just a description. And here we have also wall methods. So if you think about this human that we're working with here, that's a behavior part. So this is data part, this is data part, and here we can have the behavior part. So you can say, I can move, right? I can move. And these are parentheses are usually used for identifying a method. I can move, I can like running, walking, it's like the movement, right? I can talk, and so on and so forth. So these are behaviors, right? Behavior. So these are two things that your class consists of as a template. So by looking at this, you can answer two simple questions. What data does it contain, right? And you can get this by looking at properties and data, and what actions it can perform. And it can perform actions of flipping, it can remove profile sketch, and as you can see, even by looking at their names, properties are nouns, right? They're just basically nouns. They're answering what is it, right? Or I think, yeah, noun. And methods are verbs, right? You're telling the action actually, right? So remove, get stuck, so you're asking for something, right? Uh, you're asking to perform an action, right? So create profile sketch, flip, get stacked wall, so get, remove, right? We see that it starts with a verb. And it makes sense, right? By looking at this, we kind of understand that now we get the idea of a template. But again, if we look at properties, we may see it may seem like it doesn't have that much of data, right? But is that really true, right? Is that the all data that wall contains? And the answer is no, it's not. If you look at wall members, here this part represents everything, all methods and properties that wall actually contains. And you may ask, like, what do you mean by all? Isn't that all methods, right? Isn't that all properties that it has? And the, the truth be told, it's not. Here in members, you can see all of them, right? You can see all properties and you can see all, again, members, all methods, right? I think, and all properties, right? So as you can see, it's way much more than we had here, than we saw there. So let's look at properties. Here we have something like bounding box, category. As you can see, it has a category here, but it doesn't have it here. Does it mean that a wall doesn't contain a category? No, it does. It contains it. The main idea is that it's not displayed here. And if you try to read this here, you can see that of course that's a category that represents a category which the element resides it which the element resides in. But here we have this concept that says inherited from element. And that's the first kind of hurdle that stops us from understanding the whole concept because it kind of doesn't make sense for us at the very beginning that here the documentation and in wall case we don't see all the information. That's where this inheritance comes to play. I'm not going to talk about whether it's good or not. Most of the time it's bad. 99% of the time it's bad. And it's not something that I would leverage and I would use in my own application. You can use it sometimes, but not very often. But for the time being, you don't even know what it is, right? But the main thing that it prompts us to do, that it promises to do, is to reduce duplication of things. Uh, let's kind of think about this in our example with human. So we have human, we built this. We know that it can move, it can talk, it has age, it has height. But now we want to create another class. We want to create a class for, let's say, for the architect, right? So let's say we have a class for architect. What is a class? A class is just a template. It describes what it looks like. Let's think about what our architect looks like. It also has age, right? It also has height, probably, right? Probably, yeah. It may contain like degree, right? Years of experience, right? Years of experience, experience. I'm not gonna write everything. Degree, and other stuff. So it contains some data. So this is the part that is data, right? This part is data. If we look at your human class and your architect class, you can see that we're duplicating ourselves. That here we have a age and height, and here we have age and height. So this is the problem that occurred. That eventually we may contain like a structural engineer or some other like kind of human-like classes, right? And they will contain all the data that human contains. The same goes for the behavior, right? Our architect may contain more data, right? Because as you can see, it contains everything that human has, but only more. It contains some additional data. The same goes for methods. It contains move, right? Because it can move probably, right? It has talk, but it also has more, like it can, I don't know, model in Revit. Just some behavior that you can think of. It doesn't that matter, right? So let's name this model or like drawing skills, like draw. Probably our human being also can draw, but let's suppose that it can draw in some unique way, right? It doesn't that matter. It's the idea is in semantics, in the concept. The idea is that we repeat ourselves, that here part, this one is repeated from here. And this is what happened with Revit example. So they kind of saw that a lot of elements have the same things in common in Revit. So if you think about a wall, right? Wall, floor, they all have some similar concepts. For example, they all have category. And we don't want to repeat ourselves and say category here and category here. Instead, what inheritance tells us that we can create something base, right? For example, like element. This element would have a category, and our wall and floor would inherit from them, inherit from them. So this is that term inherit, meaning they will take everything that element takes. So it's like saying wall is an element, and it means that wall contains contains everything, everything that element does, right? That element, element, that element does. But also on top of this, it contains more. So wall has all the things that element has, but more. And that is logical because element is a base concept, right? It just contains some basic information base that is common to all elements. But wall contains something more, right? It's hostable. It can it can act as a host for other families. That's the behavior that is only uh, used by the wall, right? That is contained for the wall, not for other components, right? So if you think about family instance and wall, they're different. So family instance and wall, they are different, but at some point they're the same, meaning that they're both elements. They at least have category, right? They have category, something that is common throughout all of them. So that's the main idea of inheritance, that we're just saying that, you know what, this, whatever element, right, like wall, we say that it inherits from something, meaning it has the same data. So when you see that here, when you click on the wall and you scroll down, here you have the inheritance hierarchy. And you can see that it all starts from element, and then we have something called a host object. For the time being, it doesn't matter. Let's start with element, with the highest level. So if we look at this, that means we have element here. Element has some data. I'm gonna kind of jump back and forth. So we have element there. This element, right, contains, what do we know? That we have methods, which are behavior, which is behavior, and we have properties, which is data. All this thing, if we see here in the wall, in the inheritance hierarchy, that above it, above this wall, we have element, that means wall contains everything that element has. It contains all this data. It contains category, it contains geometry, it contains document, it contains group ID, it has information about whether it's modifiable or not, it contains its location, name, so on and so forth. So that means wall contains all this info. So that's why when you look at the members of the wall, you see a bunch of data that comes from element, right? Inherited from element, inherited from element, inherited from element. And as you can see, there's a bunch of inheritance from element. And that's only methods. Here we have also properties, data that came from element. The main concept behind inheritance that we're reusing a lot of things, right? We're not duplicating ourselves. But again, this is just for you to understand this concept. It doesn't mean that inheritance is very good for your own applications, and it doesn't mean that you should use it and a lot. But again, with careful consideration, everything can be good. But then, so it has some data, right? Like category, we saw geometry, and so on and so forth. So it has some data. Also, we learned that it has some behavior. For the time being, we're not gonna look at this, but let's suppose it has some behavior there. Behavior. And then that's the first element in the hierarchy. So if we go back to this inheritance hierarchy, if we click on the wall, we see that it also has host object above this. Then that means that there is something above it that is also an element, right? That's why it gets complicated at some point because we have huge hierarchies with Revit, inheritance hierarchy. And this host object just contains more data. So it has find inserts. So it seems like this host object just represents an object that can be hostable. And if you read about this, that's a base class that provides support for all objects that can host other objects, such as wall, roofs, and floors. So we have another object that contains only data that is that contains data that is applicable only to host objects, the ones that can host other objects. And as you can see, it just has one method, find inserts. Again, it doesn't mean that it contains a single method at all, because if you look at members, we can see again that it inherits a lot from element. So here we have find inserts, right? The method that is only applicable to host object. Element doesn't know about find inserts because family instance doesn't have this method, right? It cannot be hostable in this case, right? So that's why here we have host object, right? Host object. So host object, and we're not worried about data, but when it comes to behavior, we say find inserts, right? Find inserts, inserts, find inserts, which is behavior, inserts, which is behavior. And then if we go back to the wall, we see that wall is actually, if we go there, now it's clear that wall is basically host object and host object in its turn element. So going back here, we have the third one, which is wall. So we can say that wall is host object, and we can say that wall is element. So this is how you can get started with this. So by looking at this hierarchy, you can develop this algorithm. You're looking at it and you say, okay, whatever is above, that means wall is this. So wall is element, wall is host object. When you say that wall is something, that means you can be sure that when you go to this class and you look at its description, at its properties and methods, that means that wall contains it. So that's a very simple part how you can understand this. So you find a class that you're interested in, like a wall, you look at the hierarchy, this will help you understand what data and behavior it contains uh, in addition to these ones. So this is just data that is purely relatable to the applicable to the wall, um, but it also contains other data from these classes. So that's how you can go about this and understand these huge hierarchies. So now you know what is the namespace, you know what is the class, you know how to navigate and understand what is the hierarchy of classes and where data comes from. So now you can easily read this. So you can go here and say, okay, this data is not here, is not in here, because as you can see here, we see methods. Wall doesn't contain it here, but it's retrieved from element, right? Because here we only display things that are relatable to the wall itself, right? This kind of create profile sketch, that method that is applicable only to the wall. Let's now go to Revit and just explore this a bit. So for the time being, I'm going to be using, there are different apps, Revit Lookup. I think you may heard of this or not. Again, the main idea of this video is not to actually show you the actual development of this or like the environment that you need to set up. The main idea is that you remove this layer of magic that comes when you just get started, because usually the first thing you do is just coding right away. But I think it's important to remove this layer of magic. And we have multiple tools that allow us to analyze what Revit document contains. Because um, the main part, how you develop your application, is that you have Revit database, right? The document database, and you operate with objects that it provides you with. So if we try to draw this here, right? Revit lives, so you as some architects or some other people, they open the document, right? They open their file, their document. Here they model walls, floors, and other things. Other, all like templates, they create different templates, like view templates, right? View templates. They create different view templates. They create different types, for example, wall types, right? All these things they create in the document. This is what people create in the document, which results, it's like it's a database, right? And you can think at the very beginning of the database as just a collection of these elements, right? It's just a collection of this, a data structure. It's like a data structure, and just a collection of elements. And what you do as a developer, you analyze these elements from that database. So Revit provides you with this database, which is just a bunch of elements. So these walls, floors, view templates, and you have an ability to analyze it, right? You can analyze what already exists, which is very often what you do. Also, you can add something there, right? So you can add things to the database. So the way you can do this manually by drawing a new wall, the same you can create it via program, via Revit API, right? So you can add new elements, you can update them, right? The same way you do this manually. That's why I showed you this difference between graphical user interface and Revit API, because this way you can ask yourself more questions. If you select a wall and you change comments, right, to some value, what did you do? You updated an element. And now you can go and ask yourself, okay, if I can do this via graphical user interface, can I do this from my program? Because at the end of the day, we have Revit, we have different kind of parties that can communicate to Revit. We have me as an end user, or we can have a program that I build that communicates to Revit. And can this program just change it? I don't need to create it. I don't need to delete it. I just need to take an existing one and update it. And by asking these questions, you can kind of compare what you do manually via graphical user interface and how you can do this via code. I think that can be a good exercise for you to explore it. But now I want to show how we can explore it with different tools. We have Revit Lookup. I haven't updated the newest version, so probably when I'll show you how to download this, it will be in future videos probably. You will update the newest one. But the main idea here is that it just allows you to kind of analyze it, analyze all this database. And we know that database is just a collection of elements that Revit contains. So you can analyze single elements like saying Snoop selection. Okay, I need to, I think like this, right? And say Snoop selection. Snoop selection, and that will analyze my wall, right? So this will tell me about this information that looks pretty similar to what we had in API in documentation. And here it's really good to see the difference between class and a real object. When you look at the documentation, it just tells you what it looks like. It just tells you that it should contain this, it should contain orientation, it should contain sketch, it should contain width, but it doesn't contain actual values. When you analyze it via this Revit lookup, this is a real wall. We've selected an already built wall, and here all this information is present. For example, width, you already know the width. Wall type, you already know the wall type, and all the information is here. I'm not going to go over all the information there, but that can also be a good exercise for you to simply compare it with the documentation. So you go through the documentation, you see the information it contains, and you go to the Revit lookup and compare it. And what is interesting there is that it also follows this hierarchical thing. So you can understand the hierarchies better. So when you select a wall, we can see that everything starts with element, the same way you see that in the hierarchy. So if you go through the wall, here inheritance hierarchy, everything starts with element. So if you go to Revit API, if you go to Revit, Here we can see that here are the properties, which is just data. This is where it lives, right? So this is just data that comes, that wall contains. As you can see, that's real data. So is modifiable? True. Is it transient? False. Is valid object? True. It has level, it has location, right? It has parameters. So that's not a template, that's already an object. But all this information comes from element. It doesn't come from wall inherits this from element because it doesn't want to repeat it, right? Wall itself will contain only information related to wall. So here we have some methods, right? Also we have host object there, and we have wall. So you can kind of analyze it. So again, it doesn't mean that you should only use one, right? Either Revit Lookup or other tools like Revit DB Explorer, which is actually pretty awesome as well. So here you can also perform different analysis and just basically the same part, right? It's pretty similar, but of course it comes with its own things. Also, we can analyze its database, right? So Snoop database. So you can kind of go and get familiar with what Revit consists of in terms of objects. So this is where, if you remember, we talked about domain. So this is like the domain of Revit. So here you can see that that's the problem business had. Then domain experts communicated with developers, and based on that, what is called a ubiquitous language, that's the common language that developers and domain experts use. Um, this is like based on this, they've created this kind of objects, these classes, right? Like wall, family instance, family, element type, level, all these things, right? It's not named something like silly, it's pretty meaningful. Even if you're not familiar with programming, terms like wall, floor would be relatable because you're working with this in the real world. So that's the whole idea. So now I believe that you're pretty confident in understanding how to navigate through Revit API, how to understand each part of this, right? You know about inheritance hierarchy, you know what data comes from, you can easily analyze all its members and understand where it comes from, and analyze it with Revit with different tools like DB Explorer or Revit Lookup. So now we know what is Revit API, what are classes, how inheritance works, and you can read API docs. But now we gotta get to the topic of plugins, add-ons, and so on and so forth. First of all, they're all kind of interchangeable, like plugins, add-ons. So let's stick with just one of them. Let's stick with plugins because usually that's the one you're gonna hear the most. So that is the plugins, right? And let's think about like Revit or any other application that you may have on your local machine, right? So here we have Revit, here we have Revit. You may have AutoCAD, you may have Notepad++, right? Notepad++. You may have Visual Studio Code, or any other app that you have. It can be really pretty much anything. The main idea is that, as we mentioned before, everything starts with business. We have some needs, some problems that we would like to solve, right? Then some domain experts communicate with developers, and they kind of communicate a lot. They build what is called an ubiquitous language. That's the common language that they use. And based on this, they create domain, they create program, and everything kind of revolves around this, right? So they create a program or application, whatever we call it here. So that is the end product. So this is our Revit, this is our AutoCAD, this is our Notepad++, and so on and so forth. The main idea is that it contains the main functionality of the app. So it contains its core functionality, what it was meant to be for. And other businesses that use it, especially in our industry, because in our industry, there are a lot of different business, there are a lot of companies that use these products, for example, Revit, and they have their own way of doing different things. So they have different approaches to dealing with stuff. And Revit developers simply cannot contain all these tooling in Revit because Revit would get bloated with tons of tools that are not used by anyone, that is not universal and not generic. So in this sense, Revit focuses more on generic tools, not on the very specific ones. So even if we take a look at this example, right, that by clicking on a room, we want sections to be generated. That's not something that is going to be used by most of the people, because most of the users, probably because it may contain a lot of variables, right? The way we build it, what rules to include, and so on and so forth. So each of this is tailored for some business specific needs. So that's why, but we still like Revit, right? We still use it. It does a lot of good things for us, but we want to add additional tools that would work with what we already have. So at the end of the day, you use a tool that you love, that like meets your requirements, but you want to add some additional functionality. Like in our case, by clicking on a room, we want sections to be populated in the model. So these are called plugins. So they're just apps, right, that you can add to an existing application. So you may have multiple plugins there. Let me kind of zoom a bit here. So you may have different plugins that you can add to an existing application. Taking a top-down approach on this, right? Taking a top-down approach, what do we uh, let's understand what Revit is in a very simple terms. At the end of the day, if you go to this folder, right, Revit 2023, so program files Autodesk 2023, at the end of the day, Revit is just a bunch of files. Yeah, we can go more in depth how they get executed, what are these DLL files, what is the difference between DLL and executable file. That's not actually what we're focusing here right now. Let's take a very abstract view on this and let's say that Revit is just a bunch of files. So here, what we're going to say that Revit equals just a bunch of files. So file 1, file 2, and so on and so forth. So basically, if you think about this, since that is a local kind of app, right? So that runs locally on your machine. So you have all the files that actually make that app, because without them, app cannot run, right? That's a local application. That's a desktop application. Therefore, all the files that make this app lives there on your machine. And we can simply see that what if we add something there, right? What if we kind of somehow we create these DLL files or something that Revit tells us to do. Will that be able to execute this, right? Will Revit be able to execute this? If you follow a specific contract that Revit tells you, you will. So that's actually the way it works. Revit simply tells you the contract of what you should do, and uh, and then your command will be included within Revit. Again, getting back to the whole idea of our plugins and what we'll do most and what we do pretty much most of the time is that we have data, right? That's the main part everywhere. So we have data. That data is not ours. So when you build your own application from scratch, usually you are the one who built that data. So if we look at this, when we talked about business, domain experts communicating with developers, and eventually it comes to the product. But what they're building are these domain objects, and in Revit they are walls, floors, and so on and so forth. These are domain objects. These objects are not created by us in this case. We are using them from another software. Therefore, we gotta obtain them somehow. So that's what Revit tells us, that it says to us, we're gonna give you this data. We're going to give you access to all data that contains in your document, for example. So you're going to get data you're going to get access to the document of Revit, right, to this file. You're gonna get access to the application, meaning to Revit itself, and you will be able to perform various tasks. So at the end of the day, we have a simple contract. Revit tells us we give you data and you perform any logic that you want based on this data. So let's see how a very simple command can be built within Revit. So there's a thing called interface. For the time being, we're not gonna uh, worry about external command, just external command. We're not going to worry about these terms like interfaces and so on and so forth. But the main idea, it's a contract. That's what you need to understand. That's a contract that here Revit says, think of this that way. Revit tells us that if you implement this contract, right, if you actually put the logic into here, because if you think about this, um, Revit tells you, here's an action you can do. Like, let's name this action execute. It doesn't matter like what kind of action, just execute. Let's name this. And in here, let's say this is the place where we obtain data from Revit. And Revit tells you, I give you data, right? And inside this, do whatever you want. So that's why it's called contract because it doesn't have implementation for the time being. It just tells you that this is what you give you, but you are the one who is responsible to write body for it, right? So you're going to take this data that Revit provides you with, and you will write whatever you want. So this is what that external command is all about. It just tells you, here's what we give you, but you are the one who is responsible for actually writing logic there. As simple as that. It's not that complicated, but it's just an idea. You got to have this understanding that Revit provides you with data and you do whatever you want with this data, right? That's the main idea of any plugin here, that we just get data and do analysis, create new elements, the main part is that we gotta obtain this data from somewhere. So this is the place where Revit gives you its document, its elements, like you can obtain elements from the document. But the main idea is that it gives you a document, application, and now you can start working with this. So this is the main part of this. So to sum it up, plugins are just uh, new things you can inject, you can put to an existing application, new functionality you can put to an existing application. Eventually, once you grow more as a developer, you can build your applications as plugins. Um, like supporting plugins. This comes with learning a lot of principles like solid principles, grasp principles, and patterns, and so on and so forth. They will allow you to build clean applications that allow other people to inject, to put new functionality. But that comes with experience, and later with time you'll understand more and more, and you'll even understand why the way Revit does it, it's not the best way to do it, right? There are still a lot of drawbacks in the way they approached it, and by gaining more and more experience, you'll be able to compare what would be a better approach to do this. But that's kind of a general view of this. We can also take a look at another thing. So the main part that Revit needs, because what we checked here is that we see that Revit itself is just a bunch of files, so they're located here. And we could put our files in the same folder with Revit, but we actually do it differently. Revit tells us that you gotta put this in some specific folders and you gotta put files that are called manifests. Think of this way. Uh, if you have a file, we gotta have a file that works as the description of your command, of your application or your command. Because what you gotta understand and keep in mind that you are not writing your full application. You are, that is the Revit who is responsible for calling what you have written. That's not your responsibility. That you're just following contracts that Revit tells you. So if I go to this folder, Addons, and here that's provided by Autodesk, and here we go to this folder, you can see that here we have a bunch of add-in files, right? A bunch of add-in files. And if you open them up, you can see their content, right? And it's basically, again, think of this as just a description. As you can see here, it contains the DLL file. That's what we saw with Revit, that contains a bunch of DLL files. So probably this line tells Revit where to find your DLL file. And here, this tells you what is the class name. And we already know what a class is. So since we're not responsible for calling anything, we're just following contracts and we're giving this to Revit, right? So it's like writing your own class, right? So you're writing your own class. So some command, right? So you have some command. That is your class. Let's suppose that that is your class. You have created this execute functionality that accepts a Revit data, right? And you have done some logic there. You're not the one who is actually creating an object of this. So if you remember, class is a template and object is the actual instance of this. That's where the object is actually created. And in this case, Revit is calling it. Revit is calling it. Not you. Revit is calling it. So this is really important to understand. That's why this add-in file looks that way. So it tells it where to find this DLL. So this class that you create is located in some DLL file. Let's not worry about what a DLL for the time being. And also it tells you the full class name. So that is your class name. Full class name meaning including that namespace, the container where it is. Because you saw that we may have a class named wall, but it's located in some sort of container, which is called a namespace. And here you specify the name of your class. In our case, we have the class named command. And this information is enough for Revit because it goes, okay, I know where to find DLL. And the next question, an object of what class I should create? And we tell it this class. This way Revit can call it. So this is what is also important to understand at this moment. So you're just following contracts, but the actual calling of things is not your responsibility. That is what is done by Revit itself. So this is about plugin development. The next thing that I would like to discuss is the add-in type. So let's type add-in type. We'll learn with you that we use terms like add-in, plugins, add-ons interchangeably, right? They basically mean the same thing. The main reason why I'm going with add-in here is because that's the terminology that Autodesk went with. So that's the terminology that they use. And for this, we're gonna go with a more of a top-down approach. We're not gonna go really in depth of this because I genuinely believe that there are some topics that are easier to understand once you get your hands dirty with the code. But in previous parts, we learned about add-in file. So I'm just gonna grab some random example from the one of the directories that Revit looks for add-ins. Again, we have multiple directories that Revit looks for plugins. We're gonna learn more about this later. What directories Revit looks plugins in. But the main part here is this add-in type. We have application. Most of the time, you're going to be using either application or command. DB application, I think it's something that we're going to look over a bit later. So we have two main types there, application and command. And command. Uh, to be honest, to understand application type of add-ins, we gotta understand what is a command. Like in terms of Revit context, what is a command? And if we jump straight into Revit, you can see that you have a UI with tab and a bunch of buttons. And uh, y- you can think of you can think of each of this button as a command. So each of this button executes, performs some action, and you can call it a command. So by clicking on a wall, you create wall, right? That's just the name of the command, wall, right? You can expand this, you can use different options there. It's not that important, but each of this part is actually a command. So from our perspective, right, a command is just some functionality that is performed inside Revit. So if we jump straight back to the whiteboard, we learned with you that the main idea of our plugin development, add-in development, is that we have a contract. Let's suppose we have a contract that tells us that you're going to call method execute. Here you're going to accept data from Revit, right? That is the main part. We accept data from Revit and we just work with this data. We can manipulate with Revit's database, and we learned with you that Revit's database is just basically a collection of elements that your document contains. So we can read walls, we can create new walls, we can update existing walls, and so on and so forth. So this is what you can think of the command, right? So that is your command. Uh, and you can develop, sometimes you don't want to worry about adding your own buttons to the UI, right? So here, if we again take a look at Revit example, here we have tabs, right? So if we learn the anatomy of the UI, actually it's a good tip that whenever you want to learn something, start with anatomy. That's the approach I take a lot. So whenever I need to understand some complex topic, I'm gonna start with anatomy. And it goes not only for programming, it goes for a lot of different topics as well. So just understand what it consists of, what is an anatomy of it? So here in Revit UI, we have tabs, and inside each tab, we have button. So what if you don't want to bother with creating your own tab and adding your own buttons? You're like, you know what? I have the functionality, right? I have this functionality I've written that performs some useful things for users, and I don't want to get bothered with creating my own tab with worrying about creating buttons with some icons, putting some names, putting some descriptions, and so on and so forth. I just want to create that command and that's it. So Revit tells you for this is that, okay, you can create just a command and we will put this in a standard place. So if you're not creating UI for this, that means that Revit will put this somewhere in the standard location because your users should use your command somehow, right? And if you're not creating your own place to put it, that means Revit's got to put it somewhere, right? So in this case, they put this in the add-ins tab, and here you should have external tools if you installed one. Unfortunately, on my computer, I don't have any external tools. That's why I don't see it here. But probably if you have installed any plugins that are just command type, you're gonna find it here in the add-ins tab and I think somewhere over here. But I just want you to understand the point of this, right? So you use the command part. Command is just like any action, any operation that you want to do in Revit. So you're provided with data, right? Revit gives you data, and you just perform any action. You analyze, you do something to a Revit doc or a Revit application in general, right? Do something to Revit. So that's the main idea of plugins, right? We're not using our own application, we're using some other application, and we're just putting code to it. So that's the idea. Application is basically when you want to have your own tab, you want to have your own UI, right? Your own tab, your own button, UI in terms of Revit, right? I don't mean the UI that some of your custom UI. I mean UI that is going to be put inside of Revit, meaning Here, you want to have your own tab, you want to have your own buttons, and so on. So you're going to have tab. Inside tab, you want to have like some panel there. Panel, inside panel, you want to have some buttons, and so on and so forth. Gosh, my drawing skills really bad, so I'm not gonna draw this. Let's suppose just button. So that's where you worry about UI, and most of the time you're going to be using application type because eventually, like users want to have their dedicated tab and dedicated button for this. So it's good to have this on board. But at the end of the day, if you think about this, each application, right? Application, if you again try to understand the anatomy of this, it contains of these commands. So it just has multiple commands right now. One command, let's say command one, command two, command two. So it's just like a container of the command. So if we go to Revit and analyze the architecture tab, and let's say we are responsible for building this, right? We were responsible for creating plugin that has all the commands inside the architecture tab. So our UI would look like this. So we would have application. We would need to create our own tab. We would put the name for this, right? And we would say architecture, architecture. So we'd put the name for this. And also, like, again, if you go back and forth to Revit and to whiteboard or a piece of paper, you just go there, okay, I have a tab. That tab named is architecture. Then I have build, which is a panel. And then inside this panel, I have a command. So you would just say, okay, let's create a panel. So you'd create a panel like build, right? And now this panel will contain different commands. What commands do we have inside Revit? Wall, door, window. So here we would have different commands, right? Wall, wall command, then we would have door command, and so on and so forth, right? So we would have multiple commands there. That's the whole idea. So at the end of the day, you're using commands no matter what. It's just the idea is just like the point is in the fact whether you want to include a UI or not. So that's the main part. So this app type allows you to build your own UI inside of Revit. So put new things inside of Revit interface. So command is mostly about pure logic, right? Just logic with Revit's database, with Revit itself. But app adds more on top of this, adds an ability to uh, include your own user interface inside Revit's user interface. So that's for add-in types. And that's it for this video. That's it for this lesson. So I hope you've learned a lot of useful information that'll help you with your Revit API journey. And again, keep up with the channel. There's a lot of content on the way. So just before finishing, just quickly going over the main parts, right, of what we need to understand. That everything starts first from the business needs. That's the part that you probably get because I repeated it like thousands of times, right? And the main idea how the process of application development goes is that it starts with business needs. It goes and involves interaction between domain experts, people who understand the subject area, like architectural design, BIM, structural design, all these things like 3D modeling. They really understand the best practices and all the things that really matter. And they collaborate with developers, right? So we have this collaboration. And eventually, to be honest, to be a good developer, you gotta become a domain expert in the area that you're developing it for. So if you want to be a really good BIM developer, I like to associate myself with just being a software engineer, right? But it's important because we all build for different domains, for different subject areas. And someone builds applications for hospitals, someone's for banking systems. but we build this for BIM. I like this industry, so I understand that I gotta understand BIM and the way, what processes we have for this, what needs we have, and so on and so forth. And all this, right, resulted in Revit. So again, we're not talking whether it was Revit includes the best practices and so on and so forth, and whether, and it's totally not the whole flow, but just the main idea that out of these processes that business needed it, and if you ask yourself simple questions like why it was created, what problems did we have with manual drawing, and then with AutoCAD, the way API looks will make more sense. So Revit was invented. And basically, if we think about Revit, its core part, right? Revit's like engine core part, that's what we started with, is that that's the actual, its domain, is the way it works. It's like the heart of this, right? It's like the engine of the car. But now we gotta make sure that it can be used by different users. So we have they have created graphical user interface that is consumed by users, right? So we kind of drew it like this. So you are as a user like architect, let's go like this, architect, structural engineer, map engineer, and so on and so forth. You're using graphical user interface to communicate with Revit with its core logic. So this is the kind of communication. But Revit developers also made sure that we can use it from our own application. So this is the application that you build, and to communicate with Revit, you use API. So the whole idea is that they cared about different um, different users who may utilize their software. So they build their software, right? And they say, okay, we need that to be used by regular users like architects and so on and so forth, but also for other developers as well. So this is something that you can keep in mind for your own apps that it can be quite useful. And then because they allowed us to do these things, right? We are allowed to build plugins, add-ons, doesn't matter, a lot of terminologies there. The main idea is that we have application like Revit, and we can put a lot of different application commands, functionalities into it. So this is the main idea. So one command, another command. So again, it's just because of first part is that we are exposed to the Revit API, so we have an ability to work with its objects, classes, and so on and so forth. So we can actually communicate with the Revit, with its software. So they provide us with some information, with some data, like Revit's document, Revit's application, and we just communicate with this. And it all works based on contracts. Eventually, when you learn more about programming, you will get basically an understanding of contracts way much more, and you'll kind of get the idea that it's pretty much everywhere. If you learn about internet, if you learn about other stuff as well, you will see that their basics, the basics of them are also in contracts. So so this is the way these plugins work, right? So we're exposed to API and plus some conventions like where we need to put some files and what that file should look like, and this is like an add-in file. So we just learned that we gotta tell Revit somehow how to get our command, right? That's the main idea, right? The main question that it answers is that how to get what we have built, right? We have built, what we have built. Right? That's the main idea that this add-in file answers, right? And then somewhere you have your own files, right? And we saw that that probably should be in the DLL extension if you go back and see the moment where I show you what Revit actually consists of, that it's just a bunch of files, right? At the end of the day. Also, we'll learn about add-in types and all other useful information. But that is something that you gotta understand there. And like OOP and all these things that we've covered are also crucial there. So this is like the summary of what we went through. If you want, you can rewatch, you can take notes. Actually, more about learning information. That is something that will be on the channel later. But that's it for the time being. Again, you can find more useful links in the description, the stuff I've talked about at the very beginning. And yeah, thank you for watching. That was a pleasure explaining things to you, and it's great to be back. Thank you for watching the video.